My name is Paul Walker. It's going to be an exciting talk here. The eclipse will be exciting. I'm a member of the Vermont Astronomical Society, and that's based up in the Burlington area. I've been with them since 81 or so, 1981. So I've been here a long time. Been the secretary for 29 years. Yeah, that's about half the age of the club, almost. So this is a presentation that was that's been given that a few of the members are giving around the state, well, up in this area mostly. They have notes that they talk from. I don't rather than using those notes, I'm going to use a recording that one of the members did, or they narrated it and recorded it. So I'm going to do that instead. Much easier. I can pause anytime if someone has a question. Just raise your hand, and I'll pause it, and we can get the questions answered as they come up. That way you don't have to remember at the end. What was that? Going to ask. Let's see. I'm going to pause, and I'm going to be pausing it partway through. There's a video partway through that's in here, but it has sound. But the presentation didn't record the sound, so I'm going to pause it. I'm going to actually play the video. Oh, I was going to actually get that queued up because it doesn't really matter now. Oops. And I can just switch over when the time comes. Okay, good. Okay, and I should have tested the
presentation is about the total solar eclipse coming in April
2024. So let's talk about a few topics. Sun stuff. That will cover some basic information about the sun. Eclipse timing. When exactly to start looking for the eclipse and how long it will last. Why eclipses happen. The Earth, Moon, Sun alignments that cause eclipses. Where to look. Where in the sky the sun will be during this eclipse. What to expect. Changes in the sky and the effects we will experience on Earth during the eclipse. Safe solar viewing. How to safely view the sun during the eclipse and at all other times. So we'll talk about what's inside the sun, what you can see on the surface and around the sun, and why there are sunspots. The sun is more than 90% hydrogen atoms that are converted in the core by nuclear fusion into helium atoms, releasing much radiation in the process, raising the temperature in the core to about 27 million degrees. The radiation passes through the radiation zone, which is about 12 million degrees, into the convection zone, which has a temperature of about 4 million degrees. And then out to the surface called the photosphere, which is where we see photons of light released to space. The photosphere's temperature is around 10,000 degrees. Above the photosphere is the sun's lower atmosphere called the chromosphere, where the temperature gradually drops to about 7,000 degrees. As the radiation and particles flow out from the sun, they form the sun's outer atmosphere called the corona, which has a temperature of 2 to 3 million degrees.
Science lesson. Sorry.
The convection zone brings hot material to the photosphere, where it appears as large
cells, about the size of Texas. These cells eventually cool and flow back down into the sun in a constant process. The cells as they appear in a telescope, constantly changing. When looking at the sun, these cells appear as granulation on the surface. Spots have been seen on the sun since the time of Galileo, thought to be large storms like those on Earth. It was also noted the spots move across the face of the sun, large spots making a complete revolution in about 25 days. At the sun's equator, the rotation is faster than at the poles, which is around 30 days, because the sun is made of gas and is not solid. Enlarged images of sunspots reveals a dark center surrounded by less dark and less dense areas. The dark center is called the umbra, the outer region called the penumbra. This photo, taken by VAS member Paul Walker, shows how the size of Earth compares to the size of the sun and the sunspots. It takes 109 Earths to span the diameter of the sun. But what causes the sunspots? Magnetism. Using iron filings dropped on a horseshoe magnet, you can see the lines of magnetic force flowing from one magnetic pole to the other, concentrating at the poles. The same effect happens on the sun, created by the flow of charged particles inside the sun. Where the magnetic lines of force are concentrated on the photosphere, the temperature is reduced, producing the spots. The spots look dark because they are cooler than the surrounding area. If placed in the night sky, a large sunspot would shine as bright as the moon. This magnetogram of the sun shows how magnetism covers the entire sun, with magnetic loops reaching far into space. The number of sunspots increase and decrease in a cycle of about 11 years. Sunspots have been counted for over 270 years, revealing the cycle of times of maximum activity and minimums, like the Maunder and Dalton minimums. The sun is now approaching the maximum of cycle number 25. Daily sunspot activity can be found at spaceweather.com. Sunspots can be seen and counted in white light, which includes all the different wavelengths and colors of light from the sun. But the sun is made mostly of hydrogen. So if we look at only the hydrogen light, we can see the sun differently. White light passed through a prism shows all the colors included in the white light. This is called a continuous spectrum. Hydrogen gas emits a specific pattern of light, with a bright line easily seen in the red. This is how the sun appears in hydrogen light. Much more detail of the hydrogen gas can be seen because all of the other light radiation is omitted. Around the edge of the sun can be seen prominences, which are flares coming out of the sun. High magnification of the prominences show the material flowing along the magnetic lines. In this photo, a shield blocks the sun to allow viewing the corona and a large coronal mass ejection. Without the shield, the streams and the ejection would not be visible.
The white line you saw there was that's the size of the sun, and this is the chronograph that's blocking the light from the sun.
The sun to allow viewing the corona and a large coronal mass ejection.
Without the shield, the streams and the ejection would not be visible. The solar eclipse will be seen in 3 phases. A preceding partial eclipse that starts at 2:14 and lasts for about an hour and 12 minutes. Then totality, which starts at 3:26 and lasts for about 3 minutes. Then a succeeding partial phase, which starts after totality and it goes another hour and 12 minutes.
Well, at the red field, the totality will be about 45 seconds. Just so you know. That's why I recommend go north if you can. If you got friends up north, go visit them.
Ending at 4:36.
For a total duration of 2 hours and 23 minutes. The path of totality will begin in Mexico, cross 12 states before reaching Vermont, then continue on through New Hampshire, Maine, and into Canada. This closer view of the path shows about half of Vermont will be covered by the path of totality. This shows the Vermont counties that will be in the path of totality, and so we'll see the total eclipse. The blue line is the center of totality. The red line is the southern limit of the areas to see totality. All areas below the red line will see only a partial eclipse. For example, the town of Bennington will see about 96% coverage. This shows how the duration of totality decreases the further away from the center line you are, from 3 minutes 34 seconds at the center line to 2 minutes close to the southern limit. At the edge of the limit, totality may last only seconds. So what causes a solar eclipse? Solar and lunar eclipses are caused by specific alignments of the sun, earth, and moon. Solar eclipses occur when the moon comes between the sun and the earth. If the moon is closer to earth in its orbit, the entire sun will be blocked. But if the moon is further away from earth, the moon will not completely cover the sun, resulting in an annular eclipse. The dark shadow cast on the earth is called the umbra, where totality is seen. The lighter shadow around the umbra, called the penumbra, is where only a partial eclipse will be seen. The sun, earth, and moon must align to cause an eclipse. Only certain areas in the Earth's orbit will allow eclipses to occur. These areas are called nodes and produce both solar and lunar eclipses. The moon's orbit is tipped relative to Earth, limiting the chance of an eclipse. The sun is 865,000 miles in diameter, the moon only 2,159 miles, making the sun 400 times the moon's diameter. But the sun is 400 times further away from Earth than the moon, so they appear to be the same size in the sky, allowing for total solar eclipses. This NASA visualization shows the size of the umbra for a total solar eclipse relative to the Earth's diameter. This shadow is what travels along the path of totality. This is an actual photo of the umbra of its total solar eclipse, as viewed from space. The shadow travels across Earth's surface at over 1,500 miles per hour.
Yeah, the very center of this, of course, will be very, very dark, but it's because the sun is bigger than the moon. You get sunlight shining to on either side of it, and so it gets lighter and lighter as you get further from the center.
This shows how the path of a total solar eclipse can appear most anywhere on Earth, all depending on the position of Earth and the moon in their orbits and Earth's rotation. There must be 2 eclipses per year, but no more than 5. Similar eclipses repeat about every 18 years, called a Saros cycle. For any one location on Earth, a total solar eclipse will occur on average every 375 years. Where to look? Look to the southwest. The preceding partial phase will be about halfway up the sky at about 49 degrees. Totality will be a little lower, about 40 degrees high. Succeeding partial phase will be even lower at about 30 degrees. The sun is moving east to west during the day and heading down towards the horizon, which is why the altitude changes. What to expect? The sky will slowly dim, then quickly go dark as the umbra arrives, probably similar to twilight, but not midnight, but darker if the sky is overcast. There will be a change in temperature. Animals may react as they would at sunset. As the Earth rotates west to east, the sky with the sun, moon, and stars appears to move east to west every 24 hours. The moon orbits around the Earth every 27 days, so it appears in different locations in the sky each day. This photo shows how the moon moves west to east relative to the sun, causing the preceding partial solar eclipse, then a total eclipse, then succeeding partial eclipse. This mosaic was taken by VAS member Steve Yerby of the 2017 solar eclipse, showing all the phases. As the moon covers the sun just before totality, the sun will shine through the high mountain peaks on the moon, showing as a display known as Bailey's beads, noted by English astronomer Francis Bailey. As the last beam of sunlight passes through the lunar mountain, the effect is called the diamond ring. These effects occur both before and after totality. During totality, the sun's corona will be visible, as shown in this image by VAS member Alan Wildgust.
So this is what you do not want to miss. It's to see it in person is there's nothing else you will ever see that will look like this. And most people that see it become very emotional. You wouldn't think people would, but there's something about it that it just, it's a very emotional event. So if you're south of Middlebury, yes?
I was just curious, they said something about overcast, but what if it's seriously cloudy or raining?
Then it'll just get darker. It'll get darker, like the sun is going down. You will see nothing of the sun if it's too overcast. If it's kind of thin clouds, partial, then then you'll at least be able to see the partial phases, and you may be able to, during the little bit of time that the totality occurs, you may get a few little peaks of it through the clouds. Yes.
I don't know if you know meteorologist Roger Hill, but he was forecasting today. He said, with a grain of salt, but high cirrus clouds.
That's better than solid overcast by far.
What about rain? How would rain affect
Well, if it's raining, it's going to be heavy over. It's going to be completely overcast probably. If it's if you get sporadic rain, well, you might get some thin spots. But so say we're crossing our fingers for decent weather. I mean, it might, yes.
Sorry, keep going.
In my experience so far with solar eclipses, I've seen four or five partial eclipses and one total. I went down to Tennessee for the 2017 total eclipse. All of them had clouds.
Oh, right.
But at least with got to see something, and even in the 2017 could see enough of the corona through variable clouds that that it was well worth it.
A closer view of the corona.
Hold on. Was going to.
Well, I just had a question about Bailey's beads. They talked about the mountains on the sun causing it.
The moon.
Oh, the moon! Okay, thank you. I
Yep.
was like, how would the sun have mountains? Never mind, keep going.
Yeah, because if you look at the moon with a telescope, with enough magnification, you'll see that the edge of the moon is not perfectly smooth. You can actually see the bumps.
By VA's member Steve Yerby.
This image shows how the sky will appear during totality. The program used is Stellarium, free for download to your computer. The eclipse is about center of the image. Above left is the planet Jupiter, below right is Venus, and down near the horizon are Saturn and Mars.
So if it's partly cloudy, you probably won't. You don't even bother looking for the planets. Just focus on the sun.
You will need a completely clear sky to see these planets and maybe some of the brighter stars. Next, a video of the 2017 total solar eclipse taken in Crossville, Tennessee by VAS member Paul Walker.
Okay, now here I'm going to switch over to this is a video of the video, and there's no sound. You got to hear the sound, and the actual video is obviously better quality. Now you should hear that.
See some of that.
Yeah, we're going to be mostly clouded out, folks.
See it, Paul. I see it. I see it.
He said that one town. I don't know.
We're almost there, folks.
Animals would react different.
You can see the clouds.
Well, I think I'll go to bed.
Okay.
Glasses off, glasses off.
Oh, look at that.
Look at that. Look at that.
All right, you got that, didn't you, Paul?
That's gorgeous. Isn't it beautiful? Oh,
Yep.
yes.
Can you
And
use
you have
those
to.
rings? I do.
To see the totality. Otherwise, you
Look at that.
see nothing.
Oh, wow.
I'm scared.
Oh, wow. Glasses.
at that.
Isn't that beautiful?
It is fantastic. Oh my
Weird. 1:30.
And you can still see the effects of the fact that there's clouds passing in front.
The rays kind of like what?
Oh yeah, look at the horizon. You got the horizon looks like a sunset.
Oh, the rays coming off of it.
I know.
Soft rays.
And these are short clips.
Okay, we're coming
out
up
of
on
a
the
longer
halfway
one.
point, folks.
Oh, and through the scope. Oh, gorgeous, gorgeous.
Ain't too bad here either, Paul.
Don't have much time left. 2.5 minutes.
We were lucky it didn't have them clouds, Paul.
No, they're coming.
Or now more than we'd had. I mean, there's some there, but it's still absolutely gorgeous.
So were you happy, Paul?
Oh yeah.
Good. Look at how red it is. Look at the red.
Yeah, those are prominences around the edge.
Oh!
Oh, yeah.
Take that, Paul. Take pictures.
I am.
Isn't
Yes.
that beautiful?
Oh,
Glasses on.
glasses on. Yeah, especially now.
Oh, look how red it is.
Beautiful, beautiful, beautiful. Look at that. Oh. Filters on long enough, but boy, it was, wow, something.
You were
That
gonna say,
was something.
look at that. We had the good glasses on at that point.
Yep.
Yeah.
can still see it.
So I'll stop here for a moment. Any questions, comments?
Can you have your little cardboard mounted glasses and look through binocs?
No. No. You have to get different filters, somewhat different filters that go on the front of the binoculars. They make filters that will go on the front of the binoculars. If you try using these on the back, it's going to melt a hole right through them. It'll melt that plastic in seconds. Yeah.
So don't do that.
Do not. Do not.
Glad I asked.
Well, the safety part is at the end. They put this in the middle, but this kind of gets you kind of excited. Yeah, and as you saw that this is a context view of the event.
Glasses off, glasses off.
Oh, look at that.
Look at that. Look at that.
All right, you got that, didn't you, Paul?
Oh yeah, look at the horizon. You got the horizon looks like a sunset. Okay, we're coming up on the halfway point, folks.
You'll hear a lot of this, all the same.
Isn't that beautiful?
Oh,
Glasses on.
glasses on. Yeah, especially now.
Oh, look how red it is.
Yeah.
Yeah. So that's so the I don't know if you can see the shadow bands. There's faint. Whoops, I went back too far. Shoot, sorry about that. There's faint shadows going across the sheet there.
Yeah, especially now.
Oh, look how red
Very
it
faint.
is.
Beautiful, beautiful, beautiful. Look at that.
That's the sunlight coming through the atmosphere. You have it's just a very narrow slit of sunlight, basically, a very narrow crescent of sunlight, and that acts kind of like, it's like shining a bright light, and and so it shows the different the turbulence in the air will cause that light to be a little darker in some places and lighter in other places. And that's actually, so this is like one of the few times you can see that. But you don't always, this doesn't always occur.
Look how quickly it's brightening up.
Yeah,
Wow.
right.
Like,
That was a short night.
oh, and watch the shadow bands. Look,
It's overexposed now,
look
so
on
you
the
can't
sheet.
see it on the video.
See
But
the bands?
Where?
On this sheet right here, there's faint bands. There's faint shadows going across.
I forgot to explain to them what to look for.
It looks like a little ripple and
Yeah, it's like if you're if you're like snorkeling or whatever underwater on a sandy beach, it's what the same effect that the waves will do with the sunlight. Or you've seen underwater video with the ripples of the sunlight, but that's due to the waves, and it's essentially the same sort of thing with the atmosphere. It's waves, it's air movement in the atmosphere. It's just much more subtle. Okay, so this will go to the this will be the safety part of it. I've gone to the. Did I go to the end? No, hold on. Skip through this. Too far. Okay, there we go.
Care must be taken to view the sun at any time, not just during an eclipse. Never look directly at the sun. Projection is the easiest method. The sun can be viewed using 2 sheets of white paper. In one piece, make a small hole with a push pin or a small finishing nail, face away from the sun, and project the sun's image onto the other piece of paper. Because you are facing away from the sun, this is completely safe. This is a demonstration of the use of the pinhole projector. Punching several holes, you can show your name or design with all points of light as images
You can see a whole
of
bunch
the
of little tiny
eclipse.
crescents.
Using your hand to make a small hole will work as a solar projector.
Just not as well.
Even a small triangular shape will work to project the sun. Pinholes made by the leaves in a tree will project the sun's image too. A box can be used to project the sun with the image inside the box to provide better contrast to the image. A larger box also works to give a good view. Placing the box over your head gives you a good image. To safely view directly, only use approved eclipse glasses. Safe viewers are also made for telescopes, binoculars, and for handheld viewing. The VAS chose the hand viewer as this is easier to share with others. Use viewers only with the ISO, the International Safety Standard number of 12312-2, purchased from reputable vendors. Things to avoid: do not use sunglasses, polarizing filters, smoked glass, photo negatives, aluminum foil, or DVDs. These are not safe. VAS is not recommending the use of welder's glass.
So this is uploaded to our website, and I can give you the website. I also brought a bunch of
those very solar viewers to hand out, and our website is on that as well. So you can actually go to the website and watch this all over again. Yes?
Are the eclipses usually in the summer, or is there one season or another that?
No, it's
all a matter of when the moon passes through what they call the nodes, where it ends up being aligned to the sun and the earth, and well, so I guess right now it is kind of like be roughly you could have them roughly six months apart, but actually those nodes should be actually be in a particular orientation relative to Earth's orbit. Although the nodes do slowly essentially rotate relative to the Earth, Moon, and the Sun. So over time it shifts. But right now, you actually would get them you'd only be seeing them in the spring and in the fall. As the years go by, and I think that's part of this 18.6 year Saros cycle, where that it takes 18.6 years for the position of those nodes relative to the sun, Earth, Moon system to rotate. So it would slowly shift each year when the eclipse an eclipse can occur will shift. Yes.
Is there any advantage to having a large view shed in terms of, like, say, looking across Lake Champlain, or I guess you just need to see above 30 degrees?
Yeah, well, you for viewing it, you've got the sun's going to have to be, can't be behind trees or behind buildings.
But aside from that, is there an advantage to be in a wide open space?
No.
Okay.
No, you don't have to be in like in a field or something like that. That will ensure that you don't have any obstructions. But just take a compass and check the direction. Check your if you don't know the direction what southeast is, get a compass. But keep in mind that the magnetic north and true north are different by 15 degrees right here. So you'll be off of it. But pay attention to the sun.
See where the sun rises and sets, in particular, and where's the moon about noontime? Although, 11 o'clock, or we moved ahead, so 11 o'clock, where the moon, or 1 o'clock? Well, basically about noontime. See where the moon is, or the sun is. That's about that's due south, and then so halfway between sunset and the due south is southeast or southwest. So middle of the afternoon, 3 o'clock in the afternoon, look and see where on a reasonably clear day, see where the moon is over the next week or so, and that's where you want to look.
This photo shows how solar filters are placed on the front of telescopes and binoculars, not at the eyepiece end. It must be on the front.
Yeah.
This is an example of a glass solar filter made for a specific sized telescope. This is a funnel projector with an eyepiece at one end to be used with a telescope. The other end has rear projector material attached. This is totally safe
Eyepiece,
as the
screening.
image is projected on the back of the material. The image produced with the funnel projector is easy for many to view at the same time, and it's completely safe. The material used can be purchased. It's called Daylight Daytex Do-It-Yourself Projection Screen material. Cut to size. For more information, you can go to eclipses.aas.org. That's the American Astronomical Society, and look under Eye Safety, or eclipse2024.org. for more information on the eclipse itself. Or you can send us your questions at info@vtastro.org.
And that'll go to me and Jack St. Louis, the guy that narrated this. All right, so that's the end of the presentation. Yeah, well, we'll see. So, any additional questions?
So,
Yes.
you know, we bought some flimsy glasses from somebody. How do I know that they're really okay to use?
They should have there's a number on ISO number on them, as was shown in there.
Oh, I was going to get mine too.
Yeah, it's 123.12-2. Of course, if you're like me, it'll take you a long time to memorize that number. and chances are they have that number on them. And well, I'll see. You hand up.
This is less of an astronomical question, but like with your experience with previous eclipses, like is it worth it to try to drive somewhere north, or is it better to just sit in your own backyard here and enjoy the 45 seconds instead of getting stuck in your car for 5 hours?
Good question. I would say yes. It's worth getting stuck in your car for 5 hours.
I thought we were 3 minutes.
No.
No,
I thought that too.
that's on center line. At the center line, which is up in the northern Vermont, is 3.5 minutes. Here in Middlebury, in the rec field, is 45 seconds. Actually, 44, I think it is. You go up to Weybridge, Center Weybridge. That is I want to say 1.5 minutes.
We're all going to Alan's house then. I'm moving the party to your house.
You go up to where Route 7, where the quick stop place there was. I forget. That's about 1.5 minutes. New Haven is 2 minutes. Bristol is 2 minutes. Virgins is, I think, almost 2.5 minutes. So you gain a lot by traveling a small distance from here. Yes.
What is Burlington? Just
What's that?
what's Burlington?
That's about 3 minutes, I think. Yes. Oh, and someone over in the back had a question.
I was just curious. I've heard a lot about references to animals acting differently.
Yeah.
Have you had any experience with that?
Because they think it's sunset. Just dogs barking as it got darker down in Tennessee.
Yeah.
Some of the neighbors from where I was watching from. I was at my aunt and uncle's down there. Yeah, the dogs responded to it. Which, on the birds, there's enough birds now. You probably, if you pay attention and if you can hear them, where you're near birds, you'll probably hear them change. Of course, you have to know how their behavior changes in the evening. But we probably will start seeing crows flying back to their roost, because I see that in the evening right now.
They're moving towards nesting behavior right now, so probably not.
Yes.
It seems like just traveling west, say towards Addison.
Yes, that's also yeah, because of the angle that the sun is moving across Vermont. Yes, you can actually just go due west from here and get a longer amount of time. Because if you go to the bridge, Champlain Bridge, 2 minutes at the Champlain Bridge.
Don't tell too many people, they'll get traffic jam.
Yes. Yes. Yeah. But so if you go kind of west and north, because that's the thing, because it's probably not going to be 22. Well, I don't know. Yeah, hard to know what 22A will be an issue, because people coming up going up north in New York probably are not going to come into Vermont. Yeah, unless the weather the weather says, oh, we're going to get better weather, then you maybe see people migrating across to here, and that will be a big, the biggest unknown is where, where is it going to be clear? Because there'll be people that will be looking to see. There's websites that for amateur astronomers use to see what the actual cloudiness is going to be, and we'll be using those. Some of us will be using those. I won't. I'm going to be going to our observing site up in Heinsberg, and that's it. Because too many other people are coming, doing that so that other people can come there. So I won't be doing any last minute movements. No, and there's also on weather.gov. They have a satellite feed that you do. That they have animations that you can watch to see what the clouds are doing, and you can kind of guesstimate, where the clouds are going to be, in the next half hour or so. But it's probably going to be hard to travel around much. But if you know your back roads, stay away from Route 7. Probably stay away from 116. Although I haven't decided yet whether I'll try 116 going up to Heinsberg or take the back roads. But everybody that I talk to, I say, if you're going to be if you're going to be driving in the that day, particularly in the morning, getting somewhere, be familiar with your back roads so that, like say, Route 7 gets jammed up, get off on the parallel road. Of course, the only thing is, here you want to make sure you get on the east side because, you can get as far as Virgins on the west side, but you can't get past the Virgins without getting back onto Route 7. Yeah, yep. Of course, people with their GPS map things, they're going to be nowadays. Everyone's probably going to be like, oh yeah, we can get
around it this way.
Yeah. Yep.
I don't know if they were like, you have to have a 2-week cancellation policy for that day or something because, I don't know. So there's all this mass of people coming. Well, to me, it's sort of a maybe. If the weather's bad.
It is a maybe, yeah. Because if the forecast is like overcast and there's like absolutely no possibility, then yeah, some of these people that are planning, that aren't coming up ahead of time, particularly. Will not be coming up. But
I think if it's iffy though, people will still come.
Yeah.
An off chance or slightly cloudy, I feel pretty certain that they'll still come.
Yep.
Any more questions?
Yep. Just want to confirm, with the eclipse classes, you should not look through binoculars?
No. Do not put anything behind a telescope. Do not put viewers between an eyepiece of any sort on a telescope or binoculars in your eyes, because the heat will melt right through that plastic in just a few seconds. Yeah. Yes. Yes.
I guess I was curious. In the video, you said glasses off and glasses on.
Yeah.
How should we know exactly when it's okay? And when
Well,
it's not?
so the very safest thing is you're looking through your viewers, and you cannot, and the last little sliver of speck of sun disappears, then it's safe. I'm not going to encourage people to take them off earlier than that. Although that's the only way to really see the diamond ring effect. But you have to know exactly when it's safe. It's okay to take them off when there's while there's still a sliver of sun. And when the sun comes back, you really to be completely safe. As soon as the sun peeks back out, put your viewers back on.
So like a second or so? Or time you notice the sun, you're not going to be worried about damage?
Well, it's kind of like, have you ever accidentally glanced at the sun?
Yeah.
It's not nearly as bad as that. For to see when the sun just starts to come out, it's such a tiny sliver that it's not. And the fact that your eyes move, your eyes never sit still. If you stare directly at a little tiny spot, your eyes doing this. Your eyes are doing this, just a tiny bit. So that spreads that tiny little spot out a little bit. But again, you didn't hear it from me.
So the sunlight isn't actually more powerful on the moment of the eclipse. It's just that you're looking directly at it. That's the issue. Is that right?
Yeah.
Okay.
Yeah. Because you don't normally look at the sun. If you do, it's like it's so bright you quickly look away.
Yeah.
Yeah.
I can remember as a kid looking directly at the sun through my, making a teeny little split through in my fingers. Like I can see you blurry, right?
Right. Yep.
And
Yep. I mean, very, very briefly. Yeah, you can get it. You can get away with that. But again, if they want to say to be totally safe, you really need to reduce the amount of light from the sun, considerably. So if you look at it for a second or two after it comes out, don't worry about it. But I wouldn't. I'm not necessarily going to encourage you to. If you do, start counting 1001, 1002, and so that you. Because the biggest problem is you're not going to be paying attention to the time. It's going to be like, and 10 seconds, 10 seconds later, you may be, oh shit. Excuse my language. Yes.
I remember for the 2017 eclipse, we used a pair of binoculars to project the eclipse.
Yes, you can do. Yes, you can do.
But you're talking about melting plastic. So do you hold it one way or the other? Does that make a difference?
Well, you have to hold the objective lens, the big lens, toward the sun. The diameter of the lenses on binoculars, especially small binoculars, if you have 35 millimeter binoculars, the objective or smaller, there's a lot, there's less light. But you want to you want to try to keep the binocular so that the sunlight is going through the glass, and not if it hits you get off to the side and it hits if the binoculars has plastic parts inside, then it can start to melt those and actually burn them if you're not careful.
What about could you accidentally start a
fire on the ground if you did it in the dry grass?
No, because you're projecting a large image. Inside the binoculars, it's like you take a magnifying. Have you ever taken a magnifying glass and focus the sun on stuff? Okay, well that's inside the binoculars, and that's what you don't want hitting inside the binoculars. Hold my hand up. While the sun is shining into them. The eyepiece then will project that image larger, and depending on how far the distance, the image will get larger. The longer the distance that you project it, the larger the image. You have to refocus, of course, the binoculars to get it to focus, to have a focused image, but it's spread out. So you have even at 50 by 10 by 50 binoculars with a 2-inch lens on the front. The amount of the sunlight here in a 2-inch diameter is getting spread out like this. So it's less temperature. The lower it's less hot than just holding your hand up to the sun. If you hold it up right behind the binoculars, then yes, it's going to be you don't want to do that very long, or you won't do that very long because it'll say ouch.
Can you take a picture with your cell phone
You can, and you can take it through for the partial phases. You can take it through the viewers because you're not looking, through you're not looking through optics. You're looking through your camera. You'll need to you want to use the zoom feature. Of course, but it's a digital zoom. It's not a optical zoom, so it'll in a totality, you can do the same thing. Oh, the totality, you want to have something. Ideally, you want your camera, steadied on something, holding it on something where you can steady it or a tripod. But yeah, so you can if you want to capture your own. But don't waste a lot of time doing. Don't spend a lot of time doing that because because especially here, you got 45 seconds. By the time you get your picture, oh, it's done, it's gone. I missed it. So if you're viewing anything down this far, this close to the southern edge, don't bother. Yeah. I shouldn't be taking pictures of it, but I'm an astro imager. I like taking, it's like, so I have to. But I'm planning carefully, and part of my plan is to make sure I observe it myself. Because during the 2017 eclipse, I made myself a voice recording, and I played it back in my ear. So when you heard me say, take glasses off, that's because my voice was telling me in my ear, take the glasses off. So I was relaying what the audio was telling me. So but it was carefully choreographed. I timed it very carefully, so it was within a second or a couple seconds of true time.
When was the last time there was a total eclipse in this area? Do you know?
I forget. In the early 1960s, I think. It was after I was born, but not old enough to. Well, and it might have been cloudy too. Any other questions?
What's unique about the glasses that allow you to safely look at the sun and not damage your eyes?
Well, it blocks both the visible light, but it also blocks the ultraviolet and infrared. The sun puts out a lot of ultraviolet and infrared. The ultraviolet, of course, that's what gives you a sunburn. Well, that's going to give your retina a sunburn, or your cornea. I mean, UV is what actually over time causes cataracts. So it could actually, so if you were using viewers that that did not block enough UV, you would accelerate. If you're going to get cataracts, you would accelerate that process. And of course, the infrared will burn your eyes, except that your retinas have no heat sensors, so you won't feel it. You won't feel it. It'll burn your retina and damage your vision, and you won't feel it, and you probably won't realize it until sometime after. The damage may not show up for some time after it has occurred.
Is there a process on using the phone with a selfie style? So looking back up to the sun like this.
Oh, well, probably during totality, probably not, because it'll be fairly dark. Your camera will automatically adjust for a darker view. But also means you have to hold it steadier. It'd be like taking a picture late twilight outside, and you can even practice that. About say half an hour after the sun sets. See if you can hold your camera steady enough to get a halfway decent picture. Yes.
Is there any concern glasses and then, I've heard some stuff about if they get scratch on it, that can be an issue for your safety, or that sort of thing.
If they, well, so if the scratch is off to the side, where you're probably not going to be, looking through it, then, ideally, if it gets a scratch, throw it away just to be safe.
Yeah.
In practical terms, if it's damaged, if it's on the edge and not where you're going to be looking through it, because your pupils are very small,
Yeah.
So you're actually looking through very tiny areas of the filters with glasses. But right, you should throw it away. Of course, that'll probably happen during the eclipse. So they'll ask someone if you can borrow theirs from time to time.
Sorry.
But if you get a scratch, anywhere near anywhere other than on the very near the very edges, if you get any scratches going near the middle, then don't, just to be safe.
And that will be easy to see, or like, is it like a little smudge is going to be?
A little smudge isn't going to hurt it, but if you got if there's a scratch, if you can see a scratch, a noticeable scratch, a line on it, then don't use it.
So if somebody has heavily corrective glass lenses that they wear all the time, they can
just hold it over in front of them.
Just hold it.
Yeah. Because during the totality, you want your distance viewed. If you're wearing glasses for distance, you need glasses for distance. Wear them. If you don't wear them very often, wear them for the eclipse. Because otherwise, it'll be fuzzy. It'll be blurry, and you don't want that. You want it nice and crisp.
Thanks so much. That was very great.
You're welcome. So I have some